Hello, welcome to another session. So, in this session, we'll be dealing with electromagnetic induction. Okay, so these are the basic equations: magnetic flux B dot A, that is BA cos theta, or which is equal to integral B dot dA. SI unit is Weber, or which is equal to Tesla meter square. Its dimension ml square t square a to the power minus 1. Induced EMF epsilon is equal to minus d phi by dt. Induced current I equal to epsilon by r, which is equal to n by r d phi by dt. So phi is, that is magnetic flux. So induced EMF is nothing but differential of the magnetic flux, and induced charge is equal to I delta t, which is nothing but I, it is minus n by r d phi by dt, which is nothing but delta phi. So motional EMF induced in a straight conductor, that is linear motion, is equal to BLV. Rotation about one end is BL square omega by 2. Its SI unit is volt, and its dimension is ml square t to the power minus 1 e to the power minus 1. Self inductance. So L is equal to, that is, L is represented as self inductance, which is equal to phi by I, which is equal to epsilon by di by dt. Self inductance on a long solenoid is L is equal to mu r mu naught n square. N is nothing but the turns, A into I, which is of Henry. So the SI unit is self inductance is Henry. Dimension is ml square t to the power minus 2 a to the power minus 2. Mutual inductance M12 is equal to phi 2 by I1, and M12 equal to epsilon divided by di1 by dt. Mutual inductance of two long coaxial solenoids, M12 is equal to mu naught N1 N2 pi r square I. M12 is equal to root 3 L1 L2. So here you can see the mutual inductance and self inductance units are same, Henry, so as well as the dimension. So magnetostatic energy stored U is equal to half Li square. Your SI unit is joule, and alternating current and voltage E is equal to E naught sine omega t plus phi, because it is a sine wave, or it can be also represented as a cos wave. Okay. So IRM is equal to I naught by root 2. And phase relationship, that is for resistance, it is equal to no phase difference between V and I. For inductance, you have voltage leads the current by pi by 2. For capacitor, it is current leads the volt by pi by 2. So phi is equal to, that is angle tan inverse XL by XC, that is inductance by inductor, and this is capacitance divided by R, and phi is equal to tan inverse VL by VC VR. It is unitless and dimensionless. So these are the basic equation which is related to electromagnetic induction. Now we go for how to solve the problem. So this is a direct question. Find out the correct relation from the following. Okay, so here you can see the direct equation. 1 Weber is equal to 1 Tesla meter. That here you can see Weber is equal to 1 Tesla meter square. Okay. So the next question, magnetic flux in a closed circuit of resistance 20 ohm varies with time t as phi is equal to 4t square plus 2t square minus 15t plus 3. Calculate the magnitude of induced EMF at t equal to 1 seconds. So here, first we have to take, or we have to just write down the terminologies which they have given in the question. So first value is resistance, that is 20 ohm, and the magnetic flux, see, as the resistance varies, the magnetic flux will be moving as this function. Okay, so phi is equal to 4tq plus 2t square minus 15t plus 3. So they have given it here. So your required equation is nothing but, so magnitude of the induced EMF epsilon is equal to minus d phi by dt, as you can see in this equation. So what is it? Induced EMF is minus d phi by dt. Okay, so epsilon is equal to minus d phi by dt. epsilon is equal to, so minus d5, so you have to differentiate this particular equation. And one more thing, to solve a physics problem, definitely you have to be thorough with integration as well as differentiation. Okay, so max, so physics can't leave max. So that particular two calculus was is very important, so you have to be thorough with that. Okay, so how you solve this one? So d phi by dt, so t is your function. Okay, so instead, so 4t is nothing but 3 into 4t square, that is minus 12t square. So 2 into 2, that is 4t minus 15t plus 3. So it is like minus 12 minus 4 plus 15 minus 3, since t equal to 1 second, which is equal to 4 volt. Okay, so the magnitude of induced EMF is nothing but 4 volt. Next one. A bar of length 0.7 meter slides along a metal rails at a speed of 1 meter per second. The bar and the rail are in magnetic field of 20 Tesla, pointing out pointing out into the page. Calculate the motional EMF, electromagnetic force. So what are the variables they have given? A length, bar length is nothing but 0.7 meter, slides along a metal rails at a speed is equal to 1 meter per second, and they have given also the magnetic field MB is equal to 20 Tesla. So you're required, so just think what is the, what are, you have given they have given magnetic field, speed and length. Just think about the equation where they are connecting length, speed as well as magnetic field. So the required equation is equal to minus BLV, as you can see here. Where is it? One's equation. I think before the, not in this session. Yes, linear motion. You see, linear motion, motional EMF induced in a straight conductor is BLV. Okay, the same equation you have to put it here. So E equal to minus BLV, negative sign only applies to the direction. So they have given the direction also. So E equal to 1 into, that is meter per second, into 0.7. Since they have given in same unit, you don't have to convert it. Okay, so if they are given in centimeter, you have to convert it into meter, into 20 Tesla. Very direct equation. E is equal to minus 14 V voltage. Okay, next question. A bar of length 0.15 meter slides along metal rails at a speed of 5 meter. The same equation you are going to apply it again. The bar and the rails are in a magnetic field of 40 Tesla, pointing out in the picture. The resistance of two resistors in parallel, both 20 ohm, and the resistance of the bar is 5 ohm. What is the current in the bar? So extra point. Here we have solved what is the motional electromotive force. But here you can see that, the resistors, so they have given an additional points, since that is two resistance, they are in parallel also. Okay, so first one we will solve. What is length is 0.15 meter, B is equal to 40 Tesla, and that is speed or velocity is equal to 5 meter per second, and R1 is 20, that is, where is it, R1 is, here they have given some mistakes, it seems. Okay, fine. R1 is nothing but 20 ohm and R2 is 5 ohm. So it is 20. It is not, so R1, R2, resistance of 2, but 20, resistance is 5 ohm. Okay. So here it is 20 ohm. So R2 is 5 ohm. Okay. So EMF is that straight equation which you have given, that is 30 volt. So R1 and R2 are in parallel. So what is the equation of total resistance in for parallel connection? For series connection, R is equal to R1 plus R2 plus R3. And for parallel is 1 by R1 is equal to 1 by R2 plus R3. Okay. So what here you are getting? Here you are getting electromotive force. That is I equal to VR. V is nothing but your potential. So and total resistance is what? this parallel connection, it is 10 ohm. So I equal to what is the current? So what they have asked, what is the current in the bar? So I is equal to VR. So instead of V, it is electromotive force. So value you can apply it and you can. Okay. So our answer is 2 ampere. Next one is calculate the mutual inductance between two coils. If a current 10 ampere in the primary coil changes the flux by 500 Web per turn in the secondary coil of 200 turns. Basic equation, that is N phi is equal to Mi. So N is number of turns, phi is your magnetic flux, M is your mutual inductance, and I is your current. Okay, so N phi. So they have given 500, phi is equal to Weber, then 200 is your turns, M we have to find out, and 10 is your current. Okay. So this is a small session about electromagnetic induction. Please be thorough with your equations. Okay. Thank you. And next session we'll be dealing with nuclear physics. Thank you.